Today is about chapter 3, which is control structures. Right. The previous chapter, in chapter 2, discussed the programs that were executed in the same order in which they appeared within the program, which is we refer it as a sequence structure. However, this type of programs is unrealistic because they do not include tests to determine whether conditions is met or not. Repeated execution is required or not, and execution of individual groups of statements on selective basis is involved or not. Thus, this chapter introduced the concept of control structure, which is selection and repetition control structure, in order to construct a realistic C++ program that may require a logical test to carry out at some particular point within the program. So hopefully at the end of this topic, the student will be able to understand the concept of control structure in order to control the flow of the program, use suitable loop statement to control the repetition of the program, and use suitable selection statement to control the execution of selection structure in the program. Right? So as you can see here, did you see the notepad here? Okay, this part. Right, so in this chapter 3, you will be introduced with two subtopics, which is repetition structure and also the selection structure. For today, we learned about repetition structure. Okay, we must know why we do the repetition structure and how we can implement the repetition structure in the program. Okay. In high-level programming language, it states here, a high-level programming language. High-level. There are two types of programming language, which is low-level programming language and high-level programming language. Low-level programming language is, for example, assembly language, machine language, which can be understood by only your devices, for example, your computer, your laptop, or your mobile devices. Okay. For the high-level programming language is, for example, C++, C, Java is an example of high-level programming language, right? So this high-level programming language, such as C++, requires three basic control structure. Okay, three basic control structure, which are sequence structure, repetition structure, and also selection structure. Okay, in the sequence structure means executing one instruction after another. Okay, in the order in which they occur in the source file. This is usually built into languages as the default action, as it is with C++. Okay, if an instruction is not a control statement, then the next instruction to be executed will simply be the next one in sequence, right? So this sequence structure, you already experienced, develop the sequence structure program in your lab number 2. Okay, in your lab number 2, Introduction to C++, where you develop a program to execute from one line to another line. Okay, for one instruction to another instruction in its sequence order. Alright, for today we learn about repetition structure. Okay, what does it mean by repetition structure? The repetition structure where you will executing the same section of code more than once. Okay, please have a look at this statement. Focusing on this statement, the same section of code. Okay, the same section of code where you will execute the same section of code more than once, right? Okay, a section of code may either be executed a fixed number of times, okay, executed a fixed number of times, or while condition is true, okay, while some condition is true. C++ provide three types of three repetition statements by using while statement, do while statement, or for statements, right? So while the selection structure means, okay, you will execute different sections of code depending on a condition or value of a variable. Alright, so by using this selection structure, the program is able to execute the cost is a program is able to execute or take an action depending on different circumstances. Right, so there are three selection statements, which are if else statement, and also switch statement, right? Okay, so this is the introduction for the control structure. We have a repetition structure and also selection structure. Another structure is sequence structure. Sequence structure is was introduced to you by in chapter 2, right? So today we will go in details what is a why repetition structure and how we can implement the repetition structure. The repetition structure can be implemented by using three repetition statements, which are for loop, by using for loop, or you can use do while loop, or you can use while loop. Okay, so let's say so please look at your documents in the repetition structure. Okay, in this repetition structure, where the program will able to repeat a block of statement a number of times, or while some condition is met, right? So there are three repetition statements, which are for, while, and do while. So we look at the for statement. Right. Before we go to the for statements, maybe I can show you how does the repetition looks like in the program. So let's say you have this in your online compiler. Okay, in this program will you already execute this program so many times, right? So let's say you want to display this hello world. So after you execute compile this program, you will see hello world for only one time. Okay, if you want to, let's say, display hello world for 5 times, okay, you can if you're using sequence structure approach, you will have this C out for 5 times. Okay, I copy this and paste it here. 3, 4, and 5 times. Okay, so when I execute this, okay, I'll see 1, 2, 3, 4, 5. 5 hello world. But maybe maybe the output here you cannot read properly. So let's say I want to have a new line every time it's printed the first statement, the statement. So I add in the ENDL statement. Okay, so try to run this. So now I have 5 lines of hello world with different format as previous, right? So this is the sequence structure where you will write the code. The first line is to display the first hello world, the second line is to display the second hello world, and so on, right? But however, what if you want to display for 100 times? If you use sequence structure, you will have this same instruction for 100 times. Okay, so in that case, I think that it will wasting your time and difficult to troubleshoot if there is a problem in the code. So what you need to do is to transfer or transform this sequence structure into the repetition structure. Okay, because we want to repeatedly display this instruction. Okay, repeatedly display this instruction. So alright, I want to display this for 100 times by using repetition structure. Okay, so what I want to repeat? I want to repeat this statement for how many times? For 100 times. Okay, so since I have option to use for loop, or I can choose to use a do while loop, or I can use while loop to repeat this statement. In this case, in this example, I think I will use for loop, right? So later on, I will discuss with you the details on for loops. So in order for you to provide the for loops, you need to provide the counter, the initial first here, the task expression. Let's say I need 100, and then the increment value 1 plus. Okay, and then I provide this to indicate this is the begin of for loop. Then I provide this to indicate end of for loop. Okay, so I just want to repeat this statement for 100 times. Okay, I will repeat this statement. Repeat this statement. So repeat this statement for 100 times. Okay, how I ensure that this is repeated 100 times? Because of this I is equals to 1, I less or equals to 100, so then I plus plus, right? Okay, now I can run the code. So you have now a lots of line that display the hello world, but how to know you have enough hello world? So maybe I can provide the counter here. Okay, so now we can run it. Okay, so now I have 100 lines of hello world. Okay, so what I want to show you is by using repetition structure, I can have 1, 2, 3, 4 lines of code to display 100 times hello world. If I'm using if I'm using sequence structure, I need this statement for 100 lines. Okay, for 100 lines in the program to display the hello world, right? So this is why we learned about repetition structure. Okay, since we know why we learn the repetition structure, then we go to the how we can implement the repetition structure into the program. So you can implement the repetition structure into the program by using for loop statement, do while loop statement, and while loop statement. Okay, so let's see the for loop statement, right? So in this for loop statement, what you need to remember is the syntax. Okay, the syntax. This is the general syntax of for loops. Okay, this is the general syntax for loop. Okay, in this general syntax, this is the syntax for loop, general syntax for loop. Okay, in this for loop, as you can see here, you will have three components inside the bracket here. You need to have a for keywords followed by the bracket. Then inside the bracket there are three components. Okay, the first component must end with the semicolon. Okay, the next component, test expression, must end with semicolon, and the next component is increment expression. The third component must not end with semicolon. Okay, then open curly braces and close curly braces. Within these curly braces, you need to provide the statement, which is placed in loop body of for loop. Okay, does it work? How does the for loop works? First, it will the compiler will evaluate the initialized expression first, this part first. Then it will go to the step number 2. Okay, in the step number 2, it will evaluate the test expression. So after it evaluate the initialized expression, then it will evaluate the test expression. If the test expression is false, it will exit from the for loop, meaning that after if this expression, if the second component is false, then it will not execute anything within these curly braces. Okay, if the test expression is true, then it will go to the statement within the curly braces. After that, it will evaluate the increment expression. After it evaluates the increment expression, then it will repeat step number 2, which is it will go to the test expression, evaluate it. If this is true, then it will go inside the curly braces, do the statements here. After it finish inside this, it will go to the increment expression, evaluate it, then go to the test expression. If this is still true, it will go inside the curly braces, and then after that it will do the increment expression, then evaluate the test expression. If the test expression is false, then it will skip all these statements inside the curly braces and execute statement outside from the curly braces. Okay, so this how the for loops statement works is presented in this block diagram. Okay, in this block diagram, so you can refer to figure 3.1 to have a clear execution flow of for statement. Okay, please have a look at your diagram. So this is actually number 1. Okay, this is number 2. And this is number 3. And this is number 4. And this is number 5. Okay. So, as I mentioned before, the syntax for loop is for keyword followed by the bracket. Inside the bracket, there are 3 components. The first component, the second component, and the third component, followed by the curly braces, the open and the closed curly braces. Within these curly braces contains body of the loop, which is the statements to be executed repetitively. Okay, in this example, there are 2 lines of code that need to be repeatedly executed by this program. Okay, so in this example, the first component is count equals to 0. Second component is count less than 100. The third component is plus count, right? So these two, the cout and the cin, are the statements in loop body of for loop. Okay, and there are another statement outside of the curly braces here, which is cout out of for loop, right? So this statement, okay, in this statement, how the for loop execute the program is, okay, first when compiler see this for loop, the compiler will execute the first component. Okay, after evaluate the first component, it will go to the second component. In this second component, if the second component is true, then it will go to the inside the curly braces. The compiler will execute the cout and also execute the cin. After it execute the cin and receive the input from the user, it will go to the step number 4 here, which is the third component. The third component is represented by plus count. Okay, so then after it's evaluate the plus count, then it will go to the second component here, which is count less than 100. If count less than 100 is true, then it will come again in these curly braces to perform the cout and cin. After that, it will update the third component of for loop. Then it will go back to this second component. If the second component at this particular time is false, then it will go to the next line of the code, which is outside from the curly braces. In this program example is by executing the cout out of for loops. Okay. Alright. Then okay, we go to the example 3.2. Right? So in this example, it uses a for statement to find the total of, okay, this program is want to find the total of 100 to 105. Okay, let's say the programmer wants to find the total of 100 to 105 by using repetition structure, particularly by using for loops. Okay, so actually in order to find the total of 100 to 105, let's say the 100 and 105, 100 to 105 is is stored in the variable x. So the equation to find the total is this one. Okay, total is equal to total plus x. Okay, so total equals to total plus x, which is store the value of 100 to 105. Okay, according to the loop, right? But this equation can be simplified to this, which is total plus equals to x. Okay, this equation can be simplified by using this equation. So as you can see here, okay, line number 4 here, total plus equals to x, okay, is actually same with this one. Okay, so within this example 3.2, you can see from line 1 to line x, the repetition structure is actually on this spot. Okay, from line 2 to line number 5. Okay, let me delete this first. Right, so this line 2 to line 5 represents the repetition part, while line 7 and line 8 is represent sequence structure. Okay, line 7, line 8 and line 1 are not belong to the for loop. Okay, I repeat, line 1, line 7 and line 8 are not belong to for loop, right? Okay, as you can see in this for loop, okay, for line number 2, there are 4 statements here followed by the bracket here. Then the first component, okay, this first component must end with semicolon. The second component must end with semicolon, and the third component must not end with semicolon. Alright, so the repeated statement is this one. Okay, this line number 4 will be repeatedly executed by the compiler, right, from 100 to 105, right? Okay, so as the explained in this document, it states that the line number 1 contains the declarations of local variable, which is variable x and also variable total. Okay, for the for statement comprises of the initialized expression, okay, the test expression and the increment expression. So in this case, the x plus plus is the operator for postfix type, right? So x plus plus, okay, this is equivalent to x plus 1, okay? Whatever value hold by the x need to be added by 1. For example, let's say x is 100. So when it see this statement, then this is equivalent to x plus 1, which is 100 plus 1, it will get 101. Okay, this is postfix. Okay, this is the postfix. There are another type of operator which is plus plus x. Plus plus meaning that the plus plus is in front of the variable. So if you see the operator before the variable, so this is what we call prefix. Okay, in the prefix you need to do the adding first. In the prefix you need to do the adding first, adding with 1 first, get the results. Okay, then this result will be used in the program. Okay, right. So as you can see here, the output of the example 3.2 will be similar like this. You will get the program outputs like this, right? So how to verify that the output of the program is correct or not? So in repetition structure, we will use tracing table. Okay, by using tracing table to compare whether the program output produce the correct output or not. Okay, let's see if we can run this code to the compiler. Okay, so what you need to do is actually copy the code. Okay, actually the number here is not needed in the program, but since we cannot deselect this, so just copy this, but then you need to modify in the compiler in this program. So let's say we did all this. Before you copy and paste, you need to remember that the skeleton of the program must consist of, let's say in this program we need, this is the skeleton of the program. Okay, the IO stream. Why I need a library of IO stream? Because I need to use cout in the program. Okay, then I'll provide using namespace std, and then I do the declarations of the function name. Okay, then I provide the open curly braces to indicate this is the begin of main function. Then I will provide the close curly braces to indicate this is the end of main function, right? So in order to uh, in order to tell to the compiler this is the end of code, so the end of code for the main function, I provide the return 0 statement. Okay, now, so since I have already copied this statement, these 8 lines of code, so I should copy and paste it here. Sorry. Okay, I copy this first, then I will paste it here. Okay, so as I mentioned before, you need to remove all this numbering. This numbering is not needed in the program. Okay, so remove this first. Okay, so let's say I have already copy and paste all the program, all the statements from this file, this example 3.2 to the compiler. Then please execute the code. Okay, in this program, there are runtime error because it states here fatal error. There are so many errors here. Okay, so many error here. So as I mentioned in our previous session, the error that you need to solve is the first error. Okay, if you have so many, but you need to cater one by one. Okay, so you need to cater the first error in the list. Let's say in this example, in this error is state fatal error, the stray 342 in program. So this is happen in line number 15, line number 15. So kalau ni, I memang tahu this is about the use of the double quotation. The double quotation here is not recognized by this compiler. So what you need to do is to replace this double quotation by typing it manually. Okay. Right, it will provide the double quotation that recognized by this compiler. Right, change all the double quotation with the by typing manually the double quotation. Right, after that you try to execute, run it first. Then you will go, okay, now you don't have any error, but you have this output. Okay, right, so this output can be you need to verify whether this output is correct or not by using tracing table as provided uh, in this document. Okay, you can refer to table 3.1. Okay, I show you how you can develop the tracing table from scratch. Let's say you have this. Okay, you have line 1 to line 8, line 1 to line 8. Which part of the code that you need to provide in the tracing table? If you have so many lines here, 1 to 8 here, what you need to provide in the tracing table is in the repetition part, right? So for example, here for example 3.2, the tracing table. Okay, as you can see, you have a for x equals to 100. This is the first component. The second component is to do the testing, and the third component. So total plus equals to x. Then close. Right. So you have to draw the table. Okay, what you need to have in the table is this component, and also statement in this component. It is loops and also the increment. So in this example, we need 1, 2, 3, and 4. 4 columns. So I provide you the 4 columns. 1, 2, 3, and 4. This is x equals to 100. This is x less or equal to 105. This is total equals to total plus x, and this is the increment value, which is x plus plus is actually x plus 1. Okay, remove this so that you can see it clearly. Alright, so when the compiler compiles or execute this line of code, it will start with the first component, x with 100. Okay, then it will go to the next, okay, which is x less or equals to 105. So the x here is actually 100. Okay, less or equals to 105. So is it true 100 is less equals to 105? Yes, this is true. Okay, this is true. So if this is true, then the program will go to this line within the curly braces. So it will execute total equals to total plus x, which is, in this case, total is total plus x. The initial value of total is 0. Okay, so 0 plus the x is 100 here, 100. So now the total is 100. Okay, then finish all the statements in inside the curly braces, it will go to the increment value, which is the x plus plus here. So the initial value for x is 100. Okay, 100 plus 1 is now 101. Okay, now done executed this, it will go to the second step, which is the second component, which is this part. Okay, so now the x here is 101 less or equals to 105. Is it true 101 is less equals to 105? This is true. So when it's true, it needs to do the total, where the total plus x, the total at here is from the previous loop, which is 100 plus the value of the latest x, which is 101. Now the total is 201. Okay, then after it execute this, it will go to x plus plus, which is 101 plus 1 is 102. Okay, after it's execute the x plus plus, it will go to this column. Why? Because it stayed here. If it evaluate here, then it will go back to the second component. The second component now for the x is 102. Is it less or equals to 105? This is true. So if this is true, then the total is, the previous total is 201, and the latest value of x is 102, which is the total here is 303. Okay, and then we update the x, the increment expression. So now this is 103. Okay, 103, is it less or equals to 105? This is true. So this is true. If this is true, then we go to the inside the braces, then execute the total. Total is, the previous total is 303 plus the latest value of x is 103. So now it has 406, right? Then update the increment expression, which is 104. Okay, I don't have enough space here, so I need to copy this to another sheet. Okay, continue this. Right. Okay, 104 less or equals to 105. This is also true. Then it will execute inside the curly braces, which is total is, the previous total is 409 plus the current value of x is 104. So now the total is 610. Okay, 610. Okay, I think there is a mistake here. 510. Okay, then we update the increment value, which is 105. So now it will evaluate 105 less or equals to 105. True, still true. So it will execute the total equals the previous total plus the current value of x, which is 105. Now you have 620. Okay, 620. $655. 15. Okay, the total is 615. Then we update the expression, the increment expression. Now it's 106. So 106 less or equals to 105. This is false. When this is false, okay, this statement, the total statement and the increment statement will not be executed anymore. So it will stop executing this for loop. Okay. So in this case, the statements wants to display the last total. Okay, the last value stored in the total. So which is 650. So you can refer to this. So the last total saved in the total here is 650. Okay. So since the manual here matches with this program output, then you can conclude that this program is correct. Okay, it provides the correct program outputs, right? Okay. Right. So after we learn about the tracing table, which can be used in the step 4 of SDM, the testing and the verification step, okay, you have a look at this program. Have a look at this program. This program, when you try to run this program, it will provide the same output as in this program. Okay, it will provide the same output as this program. Okay, the difference between this program, the code here compared to the previous one is actually on this for statement. The first component is not stated in this for loop, but it's already stated in this line. Okay, this is also equivalent. Okay, this program is also equivalent with the previous. The difference is there is no third component here. There is no third component here. The first component is provided in the box, in the bracket. The second component is provided in the bracket, but the third component is missing from the bracket. But it provided in right after the total statement. Okay, if you try to execute this, you will get the similar output as in the example 3.2. Right? So this also will provide you with the same output as example 3.2. The difference is there is no statement in the first component and there is no statement in the third component. In the bracket, it just provide you with the second component. Okay, the first component is stated before and the third component is stated within the curly braces, which is right after the total expression. All right, so this type of writing the code is depending on the programmer, the level of the knowledge of the programmer. Every programmer has their own style, whether they want to provide the program in this style or this style or this style or another style. So there is no fixed a style of writing the code, right? Okay, so alright, this is about for loop. Okay, this is about the for loops. So this is actually the step number 4 of the STM, which is implementation by using C++ programming language. So let's say if you want to provide the design based on this code, the design in the STM is actually step number 3. Okay, let's say you want to provide the design. Okay, design the algorithm of example 3.2. You provide the design here by using, let's say, pseudocode, right? So how you want to provide the design by using pseudocode? Right, for the repetition part, let's say for line number 2 to line number 5, this is repetition part, the line number 2 to line number 5. Okay, you will provide for, okay, for x is assigned with 100, then x is evaluated by using this expression and then increment it by using x plus plus. Then you begin for. The curly braces here indicates the begin for. Okay, and then calculate total by using this equation. Right, then the close curly braces here indicate the end for, right? Okay, if I want to provide step number 3 in flowchart, sorry, the example 3.2 in flowchart for the line 2 to 5. Okay, step 3. Now I want to design the algorithm of example 3.2 using flowchart for line number 2 to number 5. Okay, as you can see in the line number 2, you have this first component, the second component, and the third component. Okay, so you need to consider the first component, the second component, and the third component. So if you present it in the flowchart, it will look like x equals to 100, x less or equals to 105, and then x plus plus. Okay, then you need to provide this total. The total plus equals to x will be executed if this statement is true. So meaning that if this is true, it will execute the total x. Okay, alright. So this statement is actually is a process, while this statement, since it produced the decision whether this is true or false, then you need to provide the decision symbol. Okay, if this is true, then it will execute total plus equals to x, which is this is a process, and after that it will update the x plus plus, so this is also the process. Okay, as you can remember, as you can recall, the order of the flow of execution for for loops, okay, it will execute this one first. Okay, then it will execute this expression, so it will provide the here. Then if this is true, it will go to the within the curly braces. So if this is true, then it will execute total. Then after that, it will execute this. So the flow is like this. After it execute this expression, it will go to the second component. So which is if you are referring to this flowchart, it will referring to this symbol. Okay, so you need to draw the flow. Okay, provide the connector over there. Sekejap saya buat elok sikit. Provide the connector here. So the x plus plus will execute here, right? So if this is false, okay, if the expression is false, then it will do outside the curly braces, which is 7 and 8. Okay, so this is the flowchart for line number 2 and line number from line 2 to line 5. Okay, if I want to provide the flowchart for overall code, in this example 3.2 from line 1 to line 8. Okay, I will do this the next page. Okay, so this is a step number 3, design algorithm of example 3.2 using flowchart for line number 1 to line number 8, right? Right, I already provide here flowchart for line number 2 to line number 5. This is line number 2 to line number 5. Then I need to add in a line number 1, line number 7, and line number 8. So line number 1 is about the declaration, the x and also the total equals to 0. So I set it here, set total equals to 0. Okay, right? And then after do the here, which is now I need to proceed with 7 and 8. 7 and 8 is about C out. 7 is C out. So after false here, it will execute the line number 7, which is display what? Display out of loop. After it executes step number line 7, it will execute line number 8, which is display what? It said display total of 100 to 105 is total. Okay, right. So this is the complete algorithm by using flowchart for example 3.2, right? So if I want to provide the complete the complete algorithm for using pseudocode for line number 1 to line number 8. Okay, I try to provide it here. Okay, so if I want to provide for line number 1 to line number 8, right? So first I will set total to 0. Okay, number 2 and number 5 is already provided in this algorithm. Then provide the line number 7 and line number 8. So next is display out of for loop, and then the next is line number 8, which is display total of 100 to 105 is actually total. Okay, so this is the complete pseudocode for example 3.2, right? Okay. All right. So if you can see in this example 3.3, okay, in this example 3.3, you are provided with these two fragment codes. Okay, the first for loops. This is the first for loops. And this is the second for loop. Oops. Okay. So let's say you are given with this fragment of code. I want you to draw, to design the pseudocode for first for loop. Okay, I need you to design algorithm of example 3.3 for first for loop. Okay, right? Let's say you want to design this algorithm by using pseudocode. Okay, for this fragment of code, you will have for x is equal to 1 and z is equals to 5. This is the first component. The second component of for is actually x plus z less than 200. And then the third component is x multiplied with 5. X multiplied equal to 5, meaning that this is actually equivalent to x sama dengan x darab dengan 5. Okay, multiply. This is multiply. Right? Then it has begin for and it has end for, and then it will display x. Okay, How do I know? Right, so this is the pseudocode. The pseudocode for first for loop. Right? So as you can see here, inside this one line of code, there are two parts. The first part is for statement. The second part is what will be executed repeatedly, which is the cout. Okay, so the for loop has three components. The first component consists of x equals to 1 and z equal to 5. How do I know? How you want to know? It's because it's end with the semicolon here. So this part to this part is the first component. The second component of for is actually until here. Okay, so meaning this is the second component, and the third component is exactly after the second semicolon and before the close bracket. Okay, so that's why you have this like this. This is the first component, the second component, and the third component. The begin for is actually referring to these first curly braces, and the end for here is referring to the last curly braces. And the display x is actually display is in C++ is cout, and it wants to display the x. So display x here. This is the pseudocode for the first for loop. Right? So if you try to execute this program into your online compiler, let's say I want to copy this to see the results. Okay, so I will repeat the steps, steps from the scratch. First, you need to provide the skeleton. Since I'm using cout in the program, so I need to include the IO string. Okay, then using namespace std, and then I do the declaration for the main function here. Okay, then provide the open curly braces to indicate the begin of main function. Okay, and then provide the close curly bracket to indicate the end of main function. Right, so before end of main function, I provide with return 0 statement to indicate the successful of executing the main function. So where did I place this statement? Okay, this statement, where should I place in the program? In this program, I will provide it in the line number 8. Okay. So if I try to execute this, right? So you can see here the program state, the compiler state there are two compiler error. Okay, so in this window state that there is no declaration for X, for identifier X, and also for the identifier Z. So I need to fix the first error first, okay, which is I need to provide the declaration for the X. Okay, after you fix the first error, execute, then you get the same error for the Z. So this is you using Z in the line 10, therefore you need to declare the variable before you use in the program. So in this case, I want Z is also integer type. I can write it like this, okay, like this, integer X, Z, separate by comma here, or I can provide it in this next line with integer Z, semicolon. These two lines is to declare the variable X and declares and Z as integer type. Okay, here I will provide the documentation. Declare X as integer type identifier. Okay, so the same goes to Z. Right, so here Z is identifier. Right, so execute this. So there is no more error, and the program produced the output. Right, produce the output. Here it states the output is 1, 5, 25, 1, 2, 5. This is display X. Okay, the X at this time is 1. Then it execute again this statement, and it produce 5. Execute again this, then it produce 25, and execute this line again and produce 1 to 5. And then there is no execution for this line. It will go to the step number 13, and lastly at 14. Okay, so let's say I want instead of I provide this line with one line of code, I want to make it more readable, so I provide it like this. Okay, this pattern, this style of writing the code is similar with this one. Okay, for X, this part, the line number 11 is represented as in this part, while this line number 12 is represented in bracket 4 here. Okay, line number 15 here is represented by N4 here, while this line number 13 is represented by this. Okay, so even though you change the way you're writing the code, when you run the program, you will get the same output. Okay, 1, 5, 25, and 1 to 5. Okay, so since you have this output, then you need to go to the fourth step of STM, which is testing and verification. To verify that the program produces the correct output, you do the tracing table. The tracing table is only for for the repetition part, which is line 11 to line 14. Okay, line 11 to line 14. So since in the code it provides you with for x equals to 1, z equals to 5, this is the first component. The second component is like this, and the third component is like this. Then it will provide you the cout. Okay, so how you want to draw your tracing table? So for this, as I mentioned before, you need to provide the first component, the second component, the statement when this is true, and the third component. So when you draw the tracing table, you will have 1, 2, 3, and 4 columns. So you have 4 columns here, x equals to 1, z equals to 5, x plus z is 200, and then cout x, and then the increment x times equals to 5. This is actually is equivalent to x times 5. Okay, right. So you've already developed the tracing table. Now we try to fill in this tracing table. Okay, let's do this in the next page. Okay, right. So the first is x equals to 1, z equals to 5. Then it will go to the second component by do the adding first. Then it will compare with the value here. So 1 plus 5 is actually 6. Is it less than 200? This is true. So this is true, then it need to display the x. The x here is 1. Okay, so after it execute the cout, then it will do the multiplication here, the incrementation, the increment expression. Okay, so the x here is actually x is equal to x times 5, which is x is 1 times 5. This is 5. Okay, after it do the third component, it will go back to the second component, which is this column, right? So it will provide the newest value of x, which is 5, and adding with the value of z, which is 5. So here the summation here provide with will produce with 10. Is it less than 100? This is true. So then you need to display the x, which is the x is 5. Okay, so do the expression, the third component, which is x times 5 here. So the newest x is 5 times 5, which is the newest is 25. So the newest x is 25 plus 5, where this is equivalent to 30. Is it less than 200? Yes, this is true. Then you need to display the x, which is 25. Okay, so now the x is 25 times 5. 25 times 5 is actually 125. Okay, so 125 plus 5 is 130. Okay, so 130 is less than 200. This is true. So it will display the x value, which is 125. Okay, then it will it will execute the third component, which is x is 125 times 5. 125 times 5. What is the value? Okay, the value is 625. Okay, so it will update here. 625 plus 5 is actually 630. Is it equal less than 200? No, this is not. This is false. When this is false, it will stop execute the cout and also the third component. Stop executing for loop. Okay, so what does it need to display on the screen? Is actually 1, the value of 5, the value of 25, the value of 125 here. So as you can see, the manual calculation and the output produced by the program is matches. So once it's matched, meaning that the program is producing the correct output. Okay, all right. So later on, I need you to provide the pseudocode for the second for loop, and also try to execute this program and evaluate whether the program produced the correct output or not. Okay, so we break for 5 minutes to before we discuss further about while statement and do while statement. Okay,